last lesson of chapter 1 now, which your book calls Introduction to Functions, but I'm going to say this is massive review. Absolutely massive review. So, the coordinate plane is the two-dimensional plane formed by the intersection of two perpendicular number lines. We know what the coordinate plane looks like. The axes are the two number lines. The x-axis is the horizontal one. The y-axis is the vertical one. The origin is the point where the number lines intersect. It is 0, 0. And an ordered pair is always given as x comma y, where x tells us how far and which way to move on the x-axis. Y tells us which way and how far to move on the y-axis. Whoops, didn't want to draw there. Get rid of that. Hey, look, it's the coordinate plane. The origin is pointed out on here. The x-axis and y-axis are labeled. Those red Roman numerals are the quadrants, which we've also talked about before. Quadrant 1, 2, 3, and 4. When you are labeling the quadrants, yes, you have to use the Roman numerals. You may not use Arabic numerals, which are what we use to write with. You must use Roman numerals when naming quadrants. So, first example, plotting points. Can I fit all of these? I can scroll out if I have to. So 3, 4. M is at 3, 4. That means starting from the origin, go right 3, up 4. Oops, drawing helps. I suppose I probably can't use a white pen on a white background. So 3, 4 is there. You know what? Let me just plop. And that is M. Positive numbers go right and or up. Negative numbers go left and or down. So negative 2, 0 says from the origin go left 2 and don't go up or down. So literally there. That's N. Obviously we don't use O to name points because it looks like 0. For some reason skipped P as well. R lives at 2, negative 3. So I'm going to scroll down a little bit for this. So 2, negative 3 says go right 2, down 3, which is there. That is R. S lives at 0, 2. 0 says don't move left and right. 2 says go up 2. So there's S. And T lives at negative 2, positive 6. So left 2, up 6. Plonk. Oh, that's not a good plonk. Plonk. That's a much better plonk. And that's T. That should be very, very familiar to you. That doesn't feel new. Similarly, this is not new. Identify the points and the quadrants they're in. So where is A? What's its ordered pair? Well, it's right 5 and up 6. And it's in quadrant 1. B is left 5, up 5. So B is at negative 5, 5. And it's in quadrant 2. C is left 2, up 3. So negative 2, 3. It's also in quadrant 2. D is left 2, down 2. So that's negative 2, negative 2. That's quadrant 3. E is right 3, down 4. So that's 3, negative 4. That's quadrant 4. And F is right 2, down 6. So that is 2, negative 6. And that's in quadrant 4. Okay. This type of table should look very familiar. Okay. We've done these before. So complete the table. I gave some numbers. We have an expression. So when x is 1, the next cell will read 4 times 1 minus 3. When x is 2, we have 4 times 2 minus 3. When x is 3, we have 4 times 3 minus 3. When x is 4, we have 4 times 4 minus 3. And when x is negative 1, we have 4 times negative 1 minus 3. Order of operations says multiply, then subtract. So that's what I'll do, and that'll give me my y values. So 4 times 1 is 4. 4 minus 3 is 1. 4 times 2 is 8. 8 minus 3 is 5. 4 times 3 is 12. 12 minus 3 is 9. 4 times 4 is 16. 16 minus 3 is 13. And 4 times negative 1 is negative 4. Negative 4 minus 3 is negative 7. Our ordered pairs then are 1, 1, 2, 5, 3, 9, 4, 13, and negative 1, negative 7. It's a very real chance 4, 13 won't fit on our grid. It will not. Actually, I don't even think the 3, 9 is going to fit on the grid. That's okay. If you get an ordered pair that does not fit on the grid, you don't have to plot it. It's that easy. If it fits, great, plot it. If it doesn't, not a problem. So plot the ordered pairs. Complete the table, graph the ordered pairs. So 1, 1, we can fit. 1, 1 is right 1, up 1. 2, 5, we can fit, because it's right 2, up 1, 2, 3, 4, 5. We cannot fit 3, 9, or 4, 13. They won't fit vertically. But we can fit negative 1, negative 7. Because this graph does go down 7 places. So negative 1, negative 7 is left 1 down 7. So plot whatever points you can when you're given a function.